Today we are talking about 12.5 circles in a coordinate plane, and we're going to dabble a little bit into some algebra 2 stuff, and we're going to graph some circles. So right now you see a circle plotted where the center is at the origin. So that's what we're first going to talk about, the equation to how to graph a circle if it's at the origin. If you notice, we have this triangle here. Conveniently, it's a right triangle, and we have our x and y. So if you were going to solve this for any of the side lengths, we'd do something like this, right? The Pythagorean theorem. Well, that's exactly what you're going to do for the equation of a circle if it is at the origin. But obviously, we have these flipped around. The only thing that you're going to need to do is insert the radius and number for that. Because remember, when you're doing a straight line, y equals mx plus b, we really didn't insert any numbers for x and y. They just stayed there. So likewise, x and y is going to stay, and we just got to figure out what the radius of the circle is going to be. So let's go ahead and look at another type of equation that is actually if it's not at the center or origin. Okay? Now, if you see, this is very nice for you guys. This is on the formula sheet on the back. Now, all we're doing is plugging in an H and a K. And H and K stand for the center of your circle. So you're going to put numbers here for H and K, and just like we did with it being at the origin, a number for R. So you're going to have a final answer. I'm just going to make this up off the top of my head. An equation, something like this, where you're going to have numbers for those variables. And x and y just stay there, and that's all you're going to do when you write the equation. So let's get some examples. The first two are if it's actually plotted and we got to write the equation. So if you notice, both of these have the center at the origin. So we're going to use the one where we're doing x squared plus y squared equals r squared. So we need to find our r. So if we look here, all I'm going to do is draw in my radius, and we can count for this one, and the radius is at 2. So the formula for this one is x squared plus y squared equals 2 squared, and you do have to square it for your final answer. So for the final answer, the equation of this circle to graph will be x squared plus y squared equals 4. Now pay close attention to this 2 here. That means the graph is counting by 2. So you have 2, 4, 6 as your radius now. So x squared plus y squared equals 6 squared. And then we're going to go ahead and simplify that to make your final answer as x squared plus y squared equals 36.
So now we're going to look at some examples that the center is not at the origin. So as you can see for the first example, your h will be your 0 and your k will be your -5. Your radius is going to be 3.7. So go back to your formula sheets and look at the formula. And it is written on top right there, so I'm going to plug it in. So whenever I see h, I plug in 0. So I'm going to put x minus 0, the whole thing square, plus y minus, and my k is a -5 square equals to 3.7 square. Now we have to make it look pretty, so what we're going to do is clean out things. So x minus 0 is just going to give you x squared. And for right here is going to be the negative and negative give you positive, so it becomes y plus 5, the whole thing squared. And just plug it in the calculator. 3.7 squared is 13.69. And now you are done. Okay, go ahead and try the second example by yourself. And if you get it correct, your answer will be x plus 2, the whole thing squared, plus y minus 5, the whole thing squared equals to 49.
Alright, so now it's kind of flipping it and saying, let's look at the equation and find what the center and the radius will be. So for the first one, there's nothing next to the x squared. So just like we learned, if there's nothing next to the x squared, that's got to be a 0. Now remember, the equation is already minus. So if it's minus a 4, it's going to be a positive 4 for your k value. So the center is at 0, 4. To find the radius, you're going to take the square root of 9. So our radius is going to be 3. So go ahead and see if you can get the answer to the next one for the radius and the center of the circle. Hopefully you've gotten this answer. The center is negative because that's a plus, it'll be -1. There's a minus, so it's almost like you're flipping the sign. So center is -1, 1, and then the square root of 4 gives you the radius as 2. All right, now of course it can't just be that easy. Let's go ahead and I'm going to draw out this problem. If it's not drawn out, sometimes it's easier to see what they give you. It says the point -3, 4 is on the circle. So I'm just going to put, wherever I want right now is -3, 4. And the center is at -1, 2. Write the standard equation. So remember, for the standard equation, you need the radius and you need the center. So right now, the problem provides us with one of the two. They give us the center is -1, 2. But we actually do not have the radius. We need to find our r. Hopefully that rings a bell. We're finding the length of the radius, so we're going to use the distance formula to solve it. So let's go ahead and plug in our values. We're going to use 4 minus 2 squared plus -3 minus -1 squared for the distance formula. When you go through all your calculations, you should actually get the square root of 8. And I'm going to leave it just like that, and you'll see why for a second. Don't put that in decimal. You tend to make some errors when you plug that into decimal. So now that we have the radius in the center, our second step is we're going to go ahead and substitute it. So this is our h and our k, and this is our r. So x minus a -1 squared plus y minus a 2 squared equals the square root of 8 squared. So let's make it look pretty. X minus a -1 will turn x plus 1. We go positive. The y minus 2 will stay the same. But when you square a square root, remember, that just turns into the normal number. So this will be your final answer for the equation of that circle. So let's have you guys try one on your own. Remember, draw it out, and if it helps, list center and radius to organize yourself. And you should have gotten this answer. So please let us know if you have any questions tomorrow in class with this one.
Now, the different type of questions they may ask will be, instead of giving you the center and one of the endpoints, they are telling you right now that they have 2 endpoints. So if you draw your picture, so the 2 endpoints, one is at 0, 0, and the other one is going to be 6 and 4. So now if you draw this right here, it's going to become your diameter. So we're going to do what Mrs. White was telling us. We have to have your radius, and you also have to your center. So the first thing we're going to do is we're going to use the midpoint formula to find the center. Okay, so the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. So when you plug in the point, you're going to have 0 plus 6 divided by 2, and you're going to have 0 plus 4 divided by 2. Your center is going to be 3, 2. So I'll put it right here in my chart. So now, once you have a center, you will be able to find, if you want to draw your diagram to make it easy for you to look at, that would be great. So once you have a center, you can go ahead and find your radius. So what you're going to do is you're going to use a distance formula. You're going to use the distance formula to solve for the radius. So you're going to use the distance formula right here. So we're going to do x1 minus x2, the whole thing squared, plus y1 minus y2, the whole thing squared. If you do it correctly, you should get square root of 13, and that is your radius. Put it right back to the chart. The final step that you're going to do is plug it back into the formula. So substitute the center and the radius into the standard equation of the circle and solve. So finally, and erase everything else. So if you have the correct answer, your answer will be x minus 3, the whole thing squared, plus y minus 2, the whole thing squared, is equals to the square root of 13 squared. So just clean it out. So the final answer will be x minus 3, the whole thing squared, plus y minus 2, the whole thing squared, equals to 13.
All right, see if you can do this one on your own, given the endpoints of the diameter. And if you did it correct, this should be your final answer. X minus 3 squared plus y minus 6 squared equals 25. All right, let's move on to the next section, and it's talking about different constructions with triangles and circles. We will be utilizing two of the constructions we've already done, the perpendicular bisector and the angle bisector. So if you need to go back and look, just a rough sketch, remember perpendicular bisector is one that looks kind of like that. The angle bisector, remember, looks something like that, okay? So it's just a little rough sketch so you can remember. So let's talk about the two. The first one is called the circumcenter of the triangle. When you are doing the circumcenter of the triangle, you need to know that you're doing the perpendicular bisector of the angles in the triangle, okay? I'm sorry, not angles, the sides of the triangle, okay? So what you end up doing is doing the perpendicular bisector, and then you create this circle that goes around your triangle after you complete the perpendicular bisectors. Okay, so that's the first one you need to know, and you can practice this on the website at the end. The second one is called the incenter of a triangle, and this is where you're going to use the angle bisectors, so you're going to be bisecting the angles in the triangle. You will be given a triangle first to use, okay? And then as you see, the circle is not outside the triangle, now the circle is inside the triangle. Those are the two that you're going to construct. So remember, you can use this Math Open Reference. It's on Edline, or if you want to type this in, you need to find those two that I just talked about and be ready to practice them in class.